Hi everybody, this is July 21st, 2020 speaking, David. I'm going to be talking about the extreme world of ultra-intense lasers with Kate Lancaster. I'm just going to borrow from her for a minute. That's the channel, um, the Royal Institution from the United Kingdom. Thank you for your service to science and ultimately STEM industries. Science, technology, engineering, math. For those that don't know what STEM usually stands for now. Not to be confused with stem cells. Anyways, moving forward, I had discussed about fission propulsion rocketry um, nearly a year ago, sadly, and it sat there in dead space because I was doing extreme hypotheticals talking about sputtering. It will work. The problem is the contact point. Uranium has to be in contact in order for the sputter. Unless we're able to do what ball lightning can do and pass it through a shield of a blast shield. If you can somehow get through that. Given that ball lightning does that, based off of nothing on there but testimony. He said, she said. So what I'm going to do is talk about deuterated ammonia, which is passed over magnesium, so we end up with Mg2NH3 6. So you have 18 deuterium atoms being sputtered in a separate cavity where the hydrogen, deuterium, can pass into the chamber where a tritium pellet is ultimately fired up by this design here.
You take a whole bunch, maybe a couple of hundred of lasers, and you fire them into a gold can called a hole run. And that gold can re-emits those lasers as X-rays, and the X-rays come in, compress this tiny pellet, and then it ignites, basically. What do we mean by that? You get more energy out than you've put in. That's the idea. The other thing is you can do away with the hole run and that bit and just fire the lasers directly onto the capsule. And that's the way that I more have been working on than the indirect trifle. So, what is exactly fusion? You might have heard about it, but just for the sake of argument, you haven't.
She goes into it much further with respect to what is fusion. I sincerely believe if you have a tritium pellet fired upon in a cloud plasmid helium, deuterium, in a deuterium plasma that is released from a sputter in a separate cavity using Mg2NH3 or ND3 6 that gets sputtered, thus to release the deuterium. And then we just let the magnesium get sent into a separate part of the same chamber cavity. And then now this is completely out of the magnetic field area where that you would hold the fusion thing. So, Dr. Lancaster, thank you for your service to science, sincerely. I really hope that you see this video. I hope me just referencing you that there's a bot somewhere on here that gets this information to you, and you're at the Royal Institution, which I have a lot of respect for you, and Dr. Ish and Neil, you guys over there on periodic videos, learned a lot from you. That magnetic molecular magnets was just, I literally put my phone number in the comments for a day. I'm not doing that again. Anyways, moving forward, I really think that this will work. We've been looking for a way to induce the hydrogen into there, and we know tritium is just blast ready. Maybe we can make a tritium, an NH3, an NT3 6, Mg2 NT3 6. In the meantime, and then yeah, like an original starting point. I don't know how unstable or I know that it's the kind that fuses readily. I don't know if deuterium is, but I know that under certain circumstances, under fermion plasmas, it is. And then I think once you get to that, you can run with classical hydrogen, manerium, for lack of a better word. I use this word early on in my first beginning of my videos when I was a lot more sure of my hypothetical self, the myself and the hypotheticals. Um, it's sad to say that most of my page is hypothetical, most of my channel. I'm pretty sure you can see that it holds water. I'm pretty sure that you could even sputter water. So, heavy water. I've never heard of tritium water, but Mg2NH36 is a very hydrogen dense complex. If you just get it to the point where the magnesium melts, you don't have to load it until it's a liquid. You're essentially creating the Banksir reaction or the Birch. So I sort of borrowed from methamphetamine tech, although it's not. I don't believe it's used in meth manufacture, although I'm pretty sure it could be. Good thing I'm not making that stuff, huh? Anyways, not likely that you could. It would probably strip it to the cyclo. So if you're a meth maker, I wouldn't do it. You waste your money. Um, moving forward. I had to say that because I realized what I just said. So the reality is, it would go to the cyclohexadienyl. You would just end up with the proper Birch product. Yeah, they call it the Birch byproduct, but going away from the classical chemistry and going within the nuclear chemistry, I'd never even conceived of the idea of just using tritium. So NT36, or just do heavy water with tritium instead of deuterium. Sputter that. So you have tritium ions, which are now magnetically able to be carried. Oh, fuck. This is perfect. If it's perfect, you could do it with uranium for the sake of fission power. And then ultimately that's antimatter. Because the same power that is driven off from that is antimatter. You have positrons and electrons leaving off, and then you have neutrons being out, which is ultimately nuclear. But when positrons and electrons meet, you annihilate, you end up with more energy. When you think about the Bikini Atoll, you realize here is something that blew my mind. I want you guys to realize this. They had, 35 kilos of. It was something like 35 kilos of plutonium and 700. Yeah, 700. It was either 700 grams or 700 kilograms, leaning more towards the latter. It was a big number of lithium deuteride, L7. It was the big disaster. The one where they were expecting it to remain L7, but the beryllium mirror and everything, that it was in a canister. So I have this philosophy that you can totally anti the design, invert the design, just like I mentioned with respect to sprite blades. I'm not referring to fairies. I know I said I'm a fairy, I am real. I'm talking transcendentally. I'm talking about sprites above the lightning storm. Uh, Inverting the magnetron, microwave design, incorporating a magnetron into a lightsaber handle, if you will, and then firing an X-ray laser through the magnetron while it's being electrified. So there'd be like a spark gap, like a taser, and then firing a laser through that, an X-ray laser. Should make some interesting reaction. Now, if I'm wrong, then I'm wrong. Sorry, gave you a project. But the tritium thing, obviously not everybody can get their hands on that. But if a plasma is magnetically controlled, then you can send it on its merry way down towards the artificial star. It would be a star chamber, I assure you. And if there is that kind of force being generated, we're going to Mars in weeks, not months. Orders of magnitude more powerful than anything that we've ever conceived of by way of propulsion. Reusable fuel tanks. I mean, you would be 1,000 pounds of fuel of MG NT36 or ND2, NH3. with deuterium or tritium in a separate chamber and then guiding the ions down. If you don't want to use ions, that's fine. You can actually have that go into a separate chamber, so it's deuterium in a separate chamber. It builds up from being released from the sputter and then released into where it gets electrified and then beamed into the star chamber. If it's being plasmid, it can be controlled by a magnet. So the magnetic field would hold. So you'd be able to send it in there, maybe on the shape of a cone around a ring. I'm not 100% sure. You know what I mean? I just know that if I was able to work with you guys hands on, we'd be lit up this year with fusion power. But I've already got 0 point fermion technology out on here as well, so we can go far. I want you to know that this is legit. Right now, I'm working with hypotheticals, but the 0 point, I'm about 90% sure that that's 100% correct. In other words, there might be some gaps, but the theory is sitting in my face. What did I mention with respect to 0p? Okay, so let's talk about an isotropic element. I'm sorry, molecules. This bis-bis trimethylsilylamino diphenyl phosphorono methanide uranium toluene diide. I'm sorry, uranium iodo toluene diide. Yeah. This is an anisotropic compound, aka molecular magnet. And what that means to me, is that it is a crystal, seed crystal, just by being what it is. So then, as such, you would be able to take fiber optic coated gold filament down to the atom, and you would want to make it slightly conical, so it's bigger on the one end, on the reception end, and on the end that's touching the atom, the electron orbital cloud. You want to have that sitting on a plate, on like a weight plate, like on a scale, but not an actual scale, but something. Well, that might come of value too, because it has a weight, doesn't it? It has a clockable weight. So the electrons would be constantly coming off of it, or they would come off in pulse, and there would be a constant little bit of light. So that would be caught by the fiber optic. And that's important because that's another bit of light which can be captured by the light capacitor, aka laser capacitors, that I'd mentioned in the form of cubane molecules that are wrapped in a perfectly, as best as we can, beryllium type mirror, or maybe even a lithium mirror, or God willing, one day we come up with H24 complex metal hydrogen. That would be a perfect metal, perfect mirror, or very close to it. But given we don't have that yet, beryllium mirrors are working really well. That is why we used that before with respect to neutrons, bombardment, and nuclear weapons. And that is why I see that we can go much further in 0 point tech. And I get that I'm only talking about one molecule of this bis-bis, or even you can use USB too. That's a chemical that uses the same, it's a uranium antimonide. Um, it is another anisotropic. There are vanadides. You got gadolinium, which I believe behaves the same way. So they call it a two-dimensional magnet, and that makes no sense to me. It's really molecular. It's anisotropic. And God willing, the day we find out how to organize that, a quarkian magnet, something where it doesn't have so many quarks, you'll have a lot more magnetism because you'll have a naked fermion. A naked fermion is a naked black hole. That again is hypothetical, and I like to make sure that you understand that I'm speaking only factual here. That is all that I like to do. I'm a scientist, it's what I enjoy, but I am a hypothetical scientist, so theoretically, I've given you guys the future. Enjoy the keys to the kingdom. I'll enjoy watching. Hopefully, I get to hear something about it. I don't mind an accolade here and there. Until then, Dr. Lancaster, I can't wait to see another one of your classes. I've been watching avidly. God bless you all. Love you all. Deuces. As in love and peace and love and peace.